So when making metals, there's an important parameter called hardening. And hardening, work hardening or tempering, quenching, I'm putting a lot of different things all together. But it's basically heating and cooling a thing or hitting a thing in certain ways to make something stronger or weaker. And how it works is that when you heat up something, crystals remelt. And when you cool down, crystals can form. The faster cooled, the smaller the crystals are. Now, if you heat it up, you can remelt some of the small crystals first, or some of the less stable crystals. If you cool it and heat up in more complicated ways, you might have a mixture of smaller or bigger crystals or other structures. And if you cool it really fast, you might freeze certain less stable structures in it, so you might have a really hot, so you might, if you freeze it really fast, no crystals might form. Or that you cool it down first fast, so certain structures form, then you freeze it, so they preserve. Different sized, having bigger crystals, having a mixture of different sizes might make something stronger because it might have it more distributed, the different properties, and it might fill in the little gaps. Bigger crystals can be sometimes, but it might also have, bigger crystals can have more of a solid thing that makes the whole thing more solid and strong, but they can also have major pathways where big cracks can form between the big crystals, and bigger or smaller crystals can not have as much pathways for those cracks to spread. And the mixture can kind of sometimes compensate for one another one. There's different crystal structures with different properties. But not only that, it's just that heating and cooling can change the distribution of certain metals. Because certain metals have different melting points, so they might melt more to the outside of the crystal or inside of the crystal. Such as the solid cores of crystals might be the first thing that solidifies, and the outside might be the later things. And all these complicated things might happen. Work hardening can also be done by hitting something and compressing crystals, filling up gaps and defects, or changing the crystal shape so it's stronger, making crystals more dense. I want to talk about a few ways that I think we might be able to do this to make metals a little better. One is, for example, for springs, other mechanical devices, while you're actually cooling it down and making it, maybe we flex it and move it. So if you imagine a spring, if I'm constantly flexing it and expanding it as I'm cooling it, the things that need to be more rigid will get more force and compress more, making the crystal structures more rigid and strong and more durable in that way. But the outer edges, which stretch out more, will have the defects and stuff filled in repeatedly as it stretches and stuff flows in and become more flexible and springy. So by just moving in and out, we can make the crystal structures able to handle the different stresses better. Or you can imagine this for other ones. In 3D printing, using different heating up the nozzle at different temperatures, or laser sintering heating up at different temperatures could do it, or cooling it down repeatedly with blasts of air, or heating up with blasts of air, or electrical sparks, leading to more differential hardening of more complex ones. The pressure of air could also help form it, like hydroforming and pneumatic forming and aeroforming, all ways of using pressure of either liquids or gases to do this work hardening. You can make it, sometimes it can make material over twice as hard, sometimes even more. Hardness is not the same as toughness, it's more about how scratching and denting. It comes in a way of flexibility oftentimes, but so much more properties. This is just some quick thoughts of how we do in the future. And yes, this requires more energy, but the material's performance will be enhanced. And it will require less energy than making sometimes fancier materials. So you would have materials that last longer and better, meaning maybe less materials, or you have to use it less recycle, and you don't have to use as exotic materials. So I don't know if this is better for like the environment or not, but it's a case-by-case usage. Now this does require fancier equipment. I think it would be better for the environment because making the materials in the first place, mining and extracting it, is some of the worst part. Well, thank you very much for listening. Please like and subscribe. It really helps the channel out. I'm trying to reach 1,000 subscribers in a year and 4,000 watch hours, which is really hard, but with your help, I think I can do it. Thank you very much. Good. Goodbye.